Okay, so our setup for maximum likelihood estimation of the week7 is in general very similar to what we did in week 2 for stationary VAR models. We will again work with the conditional log likelihood framework, and these here are the initial conditions, the observations on which we will condition. Then the log likelihood that we obtain looks like this. Now, what do we recognize? Well, we recognize that we have here a sum of squared residuals with the inverse variance covariance matrix sandwiched in between. Now, in week 2, we saw that the maximum likelihood estimator for the VAR parameters boiled down to performing least squares equation by equation. So a natural question is whether we can also get the parameters in our week7 through equation by equation least squares estimation. Now the answer to that question is no. And why? Well, a crucial difference with the VAR framework concerns this matrix psi here, on which we have to impose a reduced rank restriction in order to estimate our system with H cointegration relations. Remember, this reduced rank restriction implies that psi0 can be decomposed in terms of two low-rank matrices, alpha and beta. And so imposing this restriction actually means that there are restrictions across equations of our model. And so we cannot rely on equation by equation estimation. Now, what should we then do instead? Well, let's look at the maximum likelihood derivations in more detail. And to simplify notation, I will switch to matrix notation, where we can compactly write down the week7 like this. Again, we regress the series in differences on the lag of the series in levels. We still have the matrix psi0 in front of it, but I compactly collect all the lagged differences and the constant term in this new vector WT. And all corresponding parameters are collected in my matrix G. And so in this new notation, this becomes already more compact, since I more compactly expressed the term here with all of the lagged differences. Okay. Now I will take it even one step further to fully exploit matrix notation by stacking actually all of these column vectors for the different time points that are involved next to each other in new matrices. So then we have a large matrix delta Y that collects the lagged differences at all the time points in the columns. Now we still explain the lagged differences based on the lagged values of the series in levels. Again, the matrix YL stacks all of the different time points in the columns. And then these lagged differences are collected in the matrix W. In your tutorial, you will verify that the log likelihood can then be expressed in this compact matrix notation through this equation over here. Now, how do we continue with this log likelihood? Well, just like we did for the VAR, we will continue with a concentration technique. First, we will find the maximum likelihood estimator of G. So in other words, for fixed psi0 and omega, what is the optimal value of G? And once we have that, we will plug in the maximum likelihood estimator for G and continue with this concentrated log likelihood. In a last step, we will then estimate psi0, and we save this one for the end. as these are the difficult cross restrictions that need to be taken into account in this step. So let's dive in. And the first thing that we will need to do is find the optimal value for G, holding psi naught and omega fixed. Now, the steps that are involved here are rather straightforward, and we will dive into these during the tutorial. Let's rather have today a look at the intuition of what is going on the lecture slide. So we start from the log likelihood, where we need to maximize with respect to G, and we keep psi naught and omega fixed. Now, since G only pops up here in this last part here, then maximizing the log likelihood will be equivalent to minimizing this part over here, since I have the minus sign. Now we need to optimize this part with respect to G indicated in red, holding psi naught and omega fixed. Well, what do we have then over here? Well, actually, we just have, again, a sum of squared residuals. But the residuals from which multivariate regression model? Well, the WTs, that are the predictors associated with the parameters G that need to be estimated. What is the response? Well, our response is the series in differences, so delta YT, corrected for the series in levels. So this guy over here is our response. So we recognize a sum of squared residuals of this new response on all of our lagged differences. And then hopefully it will not come as a surprise that the maximum likelihood estimator for G is indeed given by the least squares of the estimator of the regression of this new response on the predictors W. And that is indeed the solution that you will obtain in the tutorial. Now we have the maximum likelihood estimator for G. Our next step is to continue with the concentrated log likelihood. What is the concentrated log likelihood again? Well, that is nothing more than the log likelihood where we plug in our MLE, or maximum likelihood estimator for G. And in the team assignment, you will verify that the concentrated log likelihood boils down to this expression shown at the bottom of the slide, where we also have a new matrix that is popping up, namely MW. Now, what is this new matrix MW? Well, if you pre-multiply this MW by a matrix Y, what do you get then? Well, you get Y multiplied by this entire thing, where I just copied over in red the definition of MW from the previous slide. Now, if we expand this term, this part in blue over here that you get is nothing more than the OLS estimate from the regression of Y on W. And so what you're left with are the residuals from the regression of Y on W. So what is this matrix MW doing? Well, that is the residual maker matrix from regressing a certain response, here Y in this case, on these guys, the W's as predictors. And this matrix also has a special property, namely if you multiply it with itself transposed, then you also get the original matrix back. Now, can we further simplify our concentrated log likelihood with this matrix? Well, yes, you will also verify that in the tutorial assignment. And if I scroll back to the assignment over here, then you will actually see that if you bring in this matrix MW, that you're essentially pre-multiplying this MW with the series in differences. And you're also pre-multiplying it with the series in levels, the YL. So it will then hopefully not come as a surprise that the residuals from these regressions will also enter in our expressions. And indeed, denote here U hat as the residuals from the regressions of the series in differences on W. And V hat are the residuals from the regression of the series in levels, YL on W. And we will show then also in the tutorial that you can re-express the log likelihood in terms of these U hats and V hats. Let us go back to the overview roadmap before we continue. What have we done already so far? Well, we've obtained the maximum likelihood estimator for G. And we also derived the concentrated log likelihood by plugging in the MLE for G into the log likelihood. So next on our plate is to look into the derivations of psi naught, which we will do in the next video.